1, 2, 3, 4, 5. 5 classes. 6. Je suis déjà. Oui.
Bonjour à tout le monde. Honnêtement, il y a plein de micros, je ne sais pas lequel. Ouais, il n'y a pas besoin de celui-là pour l'instant. Ça. Donc, je pense que vous allez pouvoir m'entendre. Bonjour à tous, bienvenue pour la saison 3 du Paris Machine Learning. A priori, nous créons la 98, Machine 3. Franck Bardol et moi-même, sommes très heureux de vous accueillir ici à Phoenix. Merci beaucoup à Franck Médy de nous avoir accueillis pour la première de cette saison. En fait, le titre vient tout simplement de. Je n'arrivais pas à trouver un bon titre pour ce Meetup, et en fait, vraiment, on est déjà en septembre, je ne comprends toujours pas. Si vous avez un peu regardé ce qui s'est passé au machine learning cet été, il y a beaucoup de choses, et c'est un peu la raison pour laquelle on essaie de faire en sorte que Roloff et Sami nous expliquent ça de Berlin et de Stockholm tout à l'heure, dans pas bien longtemps. On va essayer de faire vite, de façon à ce qu'ils puissent parler vite, et puis après qu'on ait nos autres interventions qui sont plus rapides, et après qu'on puisse simplement networker dehors. Et encore un grand merci à Steve et à Rand d'avoir sponsorisé le networking event qui vient. Donc, vous l'applaudissez encore une fois. Donc, ça, ce sera pour le mois prochain. On va avoir Christophe, on va avoir Amine, on va avoir Maxime, on va avoir Amine va nous parler des baleines. Je crois que ça fait tout ce soir. Et Rand, tu vas dire après la discussion qu'on aura avec Roloff et Sami. Voilà. Donc, le prochain slide. Une croissance relativement rapide, on est à peu près à 2500 maintenant de membres sur Paris. C'est très lourd pour nous à essayer de gérer, et que vous allez pouvoir, avec nos appels, de ne pas venir, c'est réellement un problème qui est récurrent. Il nous faut des salles qui soient relativement grandes, et il faut des gens qui acceptent de nous sponsoriser un peu pour le networking 2020, parce que simplement avoir des présentations, c'est pas la chose qu'on est venu voir faire, on peut voir ça sur YouTube. D'abord, c'est une question d'avoir une communauté qui soit plus active que simplement des gens qui viennent nous regarder des présentations. On est donc à peu près à 2500, on est à peu près sur Twitter, Facebook, donc plus, je ne sais pas si ça existe encore, si, puisqu'on utilise un Hangout. On a un groupe LinkedIn vraiment qui est intéressant pour vous si vous avez envie de mettre des annonces de job, et essayer de mettre un job entre parenthèses carrées. L'idée, c'est d'enlever tous les robots qui n'arrivent pas à comprendre cette petite partie-là des instructions, et puis réellement essayer d'utiliser soit Twitter avec un handle, soit Facebook pour envoyer vos annonces. On n'a pas besoin d'être des éléments qui vous empêchent de communiquer avec le reste de la communauté. Faites-le directement sur ces choses-là. Les seules choses qu'on fait, nous, c'est regarder si certaines choses sont absolument en dehors des sujets, mais en général, c'est pas vraiment. La majorité des gens sont relativement intelligents, mais il y a des flous partout, donc on est là simplement pour gérer les flux. Voilà. Donc, on vous demande vraiment d'utiliser tout ça, de ne pas faire en sorte qu'on soit les seuls à essayer d'être les portes au reste de la communauté. Vous avez la possibilité de communiquer avec tout le monde. L'intérêt d'avoir ces groupes un peu plus franco-français, c'est vraiment aussi de communiquer un peu sur tout ce qui est machine learning et données en France, pas parce qu'elle est très différente des restes des autres pays, mais en particulier, il y a des problématiques qui arrivent en France qui ne sont pas en fait, qui n'existent pas en fait dans d'autres pays. Donc vraiment, c'est un peu la grande leçon de tout ça. Utilisez ces choses-là. Les meetups sont là en fait pour se revoir physiquement, mais tout le reste peut se faire directement sur tous ces réseaux sociaux. Donc voici les intervenants pour ce soir. On va au prochain. Donc qu'est-ce qui se passait cet été? Alors plein de choses, plein d'annonces de gens qui sont extrêmement impliqués dans le machine learning ou pas, et qui sont impliqués dans d'autres activités qui demandent du machine learning à un moment donné. Paris a été la capitale du machine learning pendant tout le mois de juillet, avec deux grandes conférences, Code 2015 qui était à Jussieu et l'ICNL qui s'est trouvé à Lille. BPI France commence à s'intéresser au fait qu'il y ait des data scientists derrière les startups parce qu'en fait, ils s'aperçoivent que c'est vraiment la valeur ajoutée. Donc, il y a un concours qui a déjà commencé en juillet, le 10 juillet, je crois. Et puis, il y a une deuxième fournée qui arrive aux alentours de octobre et novembre. Ouais. Alors, l'intérêt, qu'est-ce qui se passe cet été? Il y a beaucoup de choses qui sont passées, et en plus, il y a beaucoup de choses qui sont allées sur Internet beaucoup plus vite que d'habitude. C'est-à-dire que la majorité des conférences de l'année étaient en général relativement lentes, à faire en sorte que les slides, les présentations, ou alors voire même les présentations vidéo soient mises sur Internet. Or, ça n'a pas été le cas cette fois-ci. On a en plus des machine learning schools à Kyoto et à Sydney qui viennent justement de mettre une partie de leurs infos en ligne. Donc ça veut dire en particulier que si vous êtes absolument totalement nouveau dans le machine learning et que vous avez envie de regarder dans la partie ingénieur des choses, c'est peut-être une bonne chose de regarder une partie de ces slides. Vraiment. Et puis il y en a certains qui veulent vraiment tout à coup du départ. Et l'intérêt, c'est peut-être de penser à des choses qui sont explicitées par les gens de Scikit-Learn, qui ont fait au moins déjà 2 présentations à SciPy 2015 et à PyCon 2015. Et qui ont plus de 4 ou 6 heures de vidéos, d'interaction avec un public, le public de cette conférence, pour apprendre le machine learning. En général, c'est l'utilisation de Scikit-Learn qui est relativement bien développée par un certain nombre de Français, et surtout vraiment apprendre à regarder des données, essayer de commencer à essayer de gérer ces données, essayer d'avoir une sorte de compréhension et de modélisation de ces choses-là. J'ai mis deux liens ici. Si vous voulez voir toutes ces présentations, elles seront à la fin sur les archives du Meetup. L'idée alors j'ai un blog qui s'appelle Nuit Blanche, qui est au départ pas du tout sur machine learning, mais à la fin il y a des spécialisations sur des tags de ML et ML vidéo qui vous permettent d'avoir accès à toutes ces informations-là qui arrivent au fur et à mesure et que je collecte sur le blog. Donc ça vous aide vraiment d'aller directement aux choses intéressantes plutôt que de penser que le domaine de vous aider à trouver tout ça par recommandation. Donc, le prochain. Alors, une chose qui semble avoir été assez évidente dans plusieurs discussions qui sont passées cet été, et en particulier la présentation de Lambutu à l'ICML 2015, c'est vraiment maintenant on commence à repenser certaines choses qui se passent dans le machine learning. Il y a beaucoup de paradigmes d'entraînement et puis de tests qui sont peut-être à revoir à un moment ou à un autre. Donc on n'a peut-être pas là, nous, en tant qu'ingénieurs, à revoir ce genre de choses, mais il faut voir ça arriver sur notre avenir dans 1 ou 2 ans, dans le sens où réellement il y a des problématiques qui commencent à s'articuler, auxquelles on n'est pas du tout habitué quand on va s'entendre de certains. Et puis à un niveau plus local, on s'aperçoit que moi je mets ça la grande convergence. On s'aperçoit vraiment que le machine learning vraiment est en train de bouffer d'autres activités d'ingénierie qui n'ont a priori rien à voir avec le computer science ou ces choses-là. J'appelle ça la grande convergence parce qu'on s'aperçoit qu'il y a beaucoup de choses qui sont faites dans toutes ces autres activités d'ingénierie qui en fait ressemblent étonnamment en fait, à beaucoup de choses qui sont déjà en machine learning. Et il n'y a vraiment pas beaucoup de choses qui commencent à les différencier. On commence même à avoir beaucoup de papiers qui sont vraiment à l'intersection de ces milieux-là. Et c'est relativement riche. Et je pense qu'en tant que communauté, on doit savoir que ça existe parce qu'on s'aperçoit que ça a beaucoup plus de dimensions que simplement la dimension d'avoir des données et d'essayer de faire le modèle dessus. On parle réellement de maintenant essayer de concevoir de nouveaux capteurs et toutes ces choses. Une autre chose qui va être un peu arrivée au fur et à mesure de l'année, mais qui semble être aussi arrivée cet été, c'est l'arrivée de podcasts, donc qui sont en anglais. Il n'y a pas encore de choses françaises là-dessus, ou de francophones là-dessus, mais s'il y en a, faites aussi. Talking Machines, qui est en train de demander un peu de l'argent pour financer sa saison 2 sur Kickstarter, et puis Ethical Machines, et je crois que l'un de nos intervenants, Olaf, est en particulier la personne derrière tout ça. Le prochain. Alors tout ça c'est bien, on va parler de beaucoup de choses, on va essayer de parler de beaucoup de choses cette année. On a essayé de faire en sorte avec Franck de mettre des dates pour toute l'année, de façon à ce que quand on commence à parler aux gens, ils commencent à nous dire oui, ce mois-ci je peux pas, on va se retéléphoner, tout ça. Bon, on essaie de faire en sorte que maintenant il y ait toutes les dates pour toute l'année, et puis ça se remplit ou ça se remplit pas, et on fait les meet-up, qu'il y ait ou pas de présentation. De façon soit on se voit plus et puis on se voit un coup, soit on apprend des choses en plus. Mais on essaie de faire en sorte qu'à partir de maintenant, les gens qui ont envie de venir sachent exactement quand est-ce qu'ils peuvent le faire, surtout à 7 mois ou 8 mois à l'avance. Ce qui nous enlève une procédure du pied, et ce qui nous permettrait aussi de peut-être mieux gérer ces histoires de salles, parce que ça commence à être une grosse pression. 3 choses qui arrivent, qui nous sommes en train de nous arriver dans la figure, et dont on va essayer de parler cette année, avec des intervenants différents, mais si vous intéressez, on est absolument ouvert à toute personne qui pourrait nous aider un peu sur certaines thématiques dans lesquelles on n'est pas vraiment spécialiste certaines fois, en particulier tout ce qui est hardware pour machine learning. Donc on voit réellement maintenant avec NVIDIA qui met beaucoup de financement là-dedans, des investissements assez énormes de tout ce qui est carte graphique, dans l'accélération de certains calculs qui sont différents. Mais en fait, on peut penser à ce genre de choses comme étant beaucoup plus grand que simplement des cartes graphiques. Il y a au moins un constructeur français qui fait 40 cartes qui sont des petits ordinateurs qui font mieux certaines choses que d'autres. Donc réellement l'intérêt pour nous, notre communauté, c'est d'essayer de comprendre, de comprendre comment utiliser toutes ces choses, mais c'est de comprendre comment est-ce que les algos en fait commencent à se coller un peu mieux en fait avec l'architecture de serveur. Donc ça c'est une chose, on va essayer de faire venir des gens qui sont extrêmement timides parce qu'ils ont pas envie de communiquer là-dessus, mais il y en a d'autres qui ont envie de communiquer là-dessus, donc on les faire venir, mais les autres, on veut qu'ils soient là aussi. Donc il faut faire passer. Deux autres choses, si vous avez vécu dans une caverne depuis 1 an ou 2, il y a quelque chose qui est absolument étonnant qui se passe en biologie, qui est en fait un processus qui s'appelle CRISPR, C9, et donc en fait qui permet de prendre des gènes et de les éditer. Et en fait, on s'aperçoit en plus qu'on peut le faire avec des opérations, genre 5 ans sur ces gènes. Ça change tout, parce qu'en fait, ça change toute la biologie. Et quand on fait ce genre de choses, vous savez que la biologie est extrêmement complexe, et comme elle est extrêmement complexe, en fait, ça veut dire en fait, qu'il y a besoin d'algos pour prendre ces choses en compte. Donc, de façon évidente, à un moment ou à un autre, il va y avoir une intersection. Dans un des podcasts, il y avait au moins un chercheur de Microsoft Research, New England, qui parlait justement de l'utilisation de certains modèles de ML2, aider un peu ces concepts ces processus de crise. Mais je pense qu'on peut aller beaucoup plus loin. Et puis, l'autre chose qui vient d'arriver à peu près en mai 2014, qui est vraiment en fait ce genre de choses, qui est en fait un séquenceur génomique qui maintenant peut séquencer tout le génome en à peu près 4 jours. c'est-à-dire que votre génome, c'est à peu près 1 milliard d'informations, sur un laptop connecté avec un USB. Ce truc se connecte à un truc USB, vous mettez votre truc dessus, et vous pouvez commencer à, au bout de 4 jours, vous avez à peu près votre génome. Ce qui veut dire qu'au lieu de se poser la question de savoir quand est-ce qu'on va faire un génome de quelqu'un pour 13 millions de dollars, c'était à peu près il y a 10 ans, on ne se pose plus la question de se dire est-ce que le génome va coûter 1 000 dollars ou 2 milliards. On va se poser la question de savoir quand est-ce que les gens vont venir à l'hôpital pour donner leur génome tous les jours. Et donc, comme il y a 1 milliard d'informations pour à chaque fois que quelqu'un donne son génome, on commence à parler d'une personne qui arrive à générer des informations absolument énormes. Et vraiment, la question de la bioinformatique pendant très longtemps, c'était une question d'assemblage. Et ces technologies, en fait, là en particulier, changent totalement la donnée du problème et changent le fait que ces problèmes ne sont plus aussi complexes. Ils étaient avant combinatoriels, maintenant ils sont en fait une. Ce qui veut dire en particulier que ça, c'était plus un problème, ce qui veut dire maintenant qu'on va être obligé d'avoir des outils pour pouvoir comprendre ce que c'est que des milliards de génomes, de milliards d'individus, pour essayer de comprendre les maladies et tout ça. Un exemple tout simple, en mai 2014, ça s'est sorti, en avril 2015, on a eu un déploiement de 4 de ces nanopores en Guinée pour faire du séquençage du virus de l'Ebola. Et en fait, qu'est-ce que vous avez là maintenant? En fait, vous avez au moins un ou deux sites, nextflu.org, qui maintenant vous donne le séquençage génomique de tous les échantillons d'Ebola qui ont été pris par CISI. Voilà, à peu près plus de 600, mais ça continue d'arriver. Donc, ce que vous pouvez voir, c'est quelque chose qui ne pouvait pas exister également. Pour chacun de ces points, vous voyez à peu près un milliard de. Donc, on commence même à avoir une idée même de la géolocalisation de chacun de ces. Donc, tout ça, c'est des choses dont on voudrait parler, dont on voudrait faire venir des gens qui nous en parlent un peu mieux, pour que nous-mêmes puissions comprendre quels sont les algos et toutes les choses à mettre en place pour essayer de faire plus. Voilà. Donc, je crois qu'on y est. On va essayer de parler directement à Salim Winnegar et à Rolf Peters. Alors, Rolf se trouve à Stockholm et Salim se trouve à Berlin. Et l'idée, c'est de faire en sorte que. Je vais rentrer. Samim and Rolf, we're going to go with you first because we don't know how these things go. We'd rather have you on. Is there a way you can screen share? We're going to mute ourselves, and you can unmute yourselves, and you can begin to have that conversation between the two of you. I don't know how you guys are going to do this, but let's have that conversation, and let's try to have the Q&A without the Doppler thingy that we had initially. If we can get those questions in, I'll try to send some emails, and you'll try to send me back some answers by voice or Hangout. So we're going to mute ourselves, and we're going to have you guys talk. And I'm going to try to see if the sound is good. It used to be good, so we should be okay. But in case it isn't, I'll take back the microphone and let you know about it.
Hello, can you hear me? How's the quality? Good evening, bonsoir. Feedback. Hugo, could you give me a sign if you hear me, and then I'll get started?
Yeah.
Yes? No?
Samir,
yes.
the sound is okay.
The sound is okay, so perfect.
Hold on a second, but the sound is not Great. We need to figure out how to amplify your voice a little bit.
Yep. Let's try this again. I apologize to everybody for this inconvenience. Technology.
Yeah.
It's a nuisance.
Est-ce qu'on peut avoir le son pour lui ou pas? Moi, je fais pas de son.
Hello. Yeah, good. Yeah, all right. Let's get started then. So, good evening, everybody. It's lovely to be back. I was at this meetup virtually earlier this summer, and I enjoyed it very much. And I'm very thankful for being invited back. So, thank you in advance. So today we're here to talk about a really busy summer that was kind of unexpectedly busy. And so the title of our very kind of ad hoc presentation is Tales from a Deeply Generative Summer, the Coming Age of Creative AI, ? And to give you some context of that, we've been surprised this summer over and over again by machine learning techniques being applied for creative tasks. So we're talking about creating pictures, creating sounds, creating text, all kinds of things that traditionally were in the domain of artists, if you like, or craftsmen, that are slowly being approachable through machine learning and AI in the general sense. And it's been, I suppose you could call this summer a bit of a big bang moment. There has been a string of very, very exciting research coming out, and accompanying that, the public perception has really shifted. So we have general public awareness growing for generative systems, which is fairly interesting. Now, one of the most interesting switches or developments in the last couple of months is that you see progressively machine learning, deep learning scientists and artists discovering that they can do art, and discovering that art is a system that they can work with. And so there's been very bright minds coming into this creative AI, what we call creative AI space, and so it's been very interesting. So maybe, Roloff, you want to explain a bit from here?
Yeah, yeah, because it's my first time at this meetup. Let me just say who I am and how I got in contact with Samim as well, and what is the origin story of our collaboration. So I'm mostly located in Stockholm, where I'm a graduate student, PhD student at a technical university there. And I also am a data scientist. I have my own data science consultancy, mostly machine learning. And most of the time, I'm very much busy with deep learning and neural networks, and not so much with art, actually. But yeah, this is kind of what for me is very interesting, because my research is between vision and language, and how do you connect these things together. And I very much look at graphical models for these things. So the graphical component is there, and that's kind of where, you know, when Deep Dream came out, was kind of a godsend present for me to kind of dig into these neural networks, what is going on, not just arithmetically, but also visually. So that's who I am and where I come from. And yeah, Samim and I, we met each other. Actually, we have never really met. We still only meet online. We still have to drink that coffee in reality. But basically, I think I gave a talk on ConfNet at a conference in London, where a small part of my talk was on, or another small talk was on the ethics of machine learning and deep learning specifically, and where I basically, well, it was not very well received, but it was an idea of thinking about these things ethically. And I think I termed something of a Hippocratic oath for data science, and this is where Samim jumped in, who was interested in that, and somehow this idea of ethics took a detour into creativity, which is very much together. ethical questions, they're hard to explore, but they can be explored through art forms and through experiments. So that's kind of what we found ourselves doing when Deep Dream was released, and we had all kinds of crazy ideas, and we decided to team up and do these kind of things. So to make a very long introduction short again, yeah, this is kind of where Deep Dream came out. It was released, and a bunch of people from the creative space, as well as some AI researchers, started to explore these things. So what I would like to do is just, probably you've all seen it, is just kind of share my screen with you. And how we'll do it is that because Samim is muted, because that will fuck up the sound. We'll probably do something like a hand wave signal when Samim wants to jump in, and then I will just try to shut up and let Samim take over. Good for you, Samim. We haven't discussed this earlier.
Yeah, no, this is great. I mean, maybe I'll add one little tidbit. So we've been, Rudolf and me, we've been collaborating extremely deeply the last 3.5 months. And it's a testament to the internet way of doing things, as we never met in person, but we've probably accomplished more than a lot of people that meet every day in person. So I love these kinds of internet stories, so this is why we share this bit with you. So Roloff, go on.
Yeah, great. So we have an agenda for today. I'm not sure if you're seeing the slides we sent, but I'll just share my screen and show them in any case. Let me see here. Yeah, I'll just share my entire screen with you, and then I have no secrets anymore. So these are the slides of today, of our talk, which we'll try to wrap up a bit. So we know that already. So we'll basically tell a bit about Deep Dream and some of the things which are going on there, and also how creative arts and AI are kind of related. And then we kind of will tell a little bit about all the developments within this thing, which has been known now as Deep Dream, and future things like StyleNet, and also the kind of rapid increase in commercial applications for these things. And the interplay between commercial parties and AI researchers. Yeah. So indeed, it's been a busy summer. So the beginning of it all, basically, as it's written in this blog post by some researchers and interns at Google, who basically developed this idea of when you take a neural network and you put it on its end the other way around, you can kind of, instead of asking the network only to classify things, so you have a deeply trained neural network like ImageNet style, and instead of just saying, well, big deep neural network, tell me what I see, you actually say, not only tell me what I see, but also visualize it for me in a normalized, gradient ascent way. And this is a kind of interplay which is then interesting to produce all kinds of nice pictures, but also can actually give you more of an insight of what is going on in these networks. It's exactly what interests me a lot there. Yeah, so there is nice IPython notebooks which are released and different people play with. So the nicest thing here is that anybody can actually run these things quite easily if you know at least how to set up some of these libraries. So this really opens the space for a lot of people to play around with these things in different ways. So one of the first things, and it's kind of what grabbed a lot of attention, is that I applied this kind of network for not just simple images, but try to apply it to a sequential image with a very simple blending factor in between the images, so you have some continuity between them, and apply it to a video. And I'm asked to not release the sound here because it's copyrighted and will be shut down by the algorithms from the Google Hangout. But most of us maybe have seen this thing. So it's a very freaky scene of fear and loathing in Las Vegas, and you apply this Deep Dream algorithm or network, and basically what you get in return is these visualizations. with, of course, especially a lot of dogs, because the ImageNet 2012 at least has as one of the training tasks to classify different breeds of dogs. So these networks are very much fine-tuned to recognize dogs. So this immediately also released the idea of puppy slugs, these fucking dogs which show up everywhere when you make things for Deep Dream. So one of the first things Samim and I did when we looked at this thing is, how can we get rid of the dogs? Yeah.
Maybe I'll jump in here, because I love watching that video over and over. It's still fun. So just leading up there, so when Rudolph released the Fear and Loathing in Las Vegas video, and it received about 1 million+ views on YouTube in a week, and you know, countless journalists and news articles jumped on it and so forth, and it was a real pop culture moment, in a sense, a real pop culture event, if you like. The whole Deep Dream thing, with millions, not millions, but maybe hundreds of thousands of people creating images of their own and so forth. And this was quite interesting. We haven't seen such a pop culture implications of a machine learning system since fractals, and you know, if that's a machine learning algorithm is to be debated. So that was very interesting. And funny enough, simultaneously, Roloff and me were thinking about so making these animation experiments more accessible, and also for the general public more accessible. And we found ourselves separately building animator Python tools for making Deep Dream animations. And so maybe Roloff, you can put on those GitHubs if you like. Yes.
Yes, exactly. So yeah, so exactly, that's kind of, so we independently started to play with these things, and then said, well, this is really strange, you know, both of us doing the same thing, we should do this together. So there's these GitHub repositories with some simple implementations of this code where anybody can play with. And this is very interesting for different reasons. One, because it's extremely simple, but by also this way, it actually really allows people to, first of all, collaborate on these things. So you see a lot of commits. There is a lot of contributors already on this particular repository which I created, and then there's, you know, issues and stuff, and people taking this further. And the same actually what happened for a similar code base of Samim, where I actually, again, you know, stole things from, etc., in the normal Git way, which now again parts are used for this other algorithms, again, like neural style and stuff like this.
Maybe so these libraries, especially Roloff's, but mine as well, have been, you know, forked hundreds of times and so forth, and it's been very enabling for people who are traditionally not familiar with machine learning algorithms to use such accessible tools. And what it really fundamentally does, it steers interest in people that have not been exposed to this technology, and it gets them involved and fascinated. And we all know that fascination is the beginning of learning, really. So part of why this is important for the general machine learning scene at large is that it gets more people involved, and that is very fascinating. So, you know, we've received literally hundreds of videos at this point using this technology to do their own animations and so forth. And the important takeaway is that these generative systems, and we will get back to this, but that these generative systems, when coupled with a strong user interface or user experience, are 10x more powerful, that they become really design tools, in a sense, like a Photoshop or an After Effects. And this is a very important takeaway, something we haven't seen fully realized in the market yet. I mean, sure, you and I, we can boot up Cafe on a machine and we can install a couple of nets and play with it, no problem. But for general audience people, it is very much a problem. And so it's been fun, actually, in this Deep Dream hype, in a sense, to watch people struggling to install Cafe deep learning framework on their Windows PC, and, you know, sending desperate midnight emails. Oh, dependency hell. So fun moments, really.
Yes, so to jump in here, you can already see some. We have some different different angles. So for me, it started out as more as a research tool, which then got really interesting in many other ways. And for Sigmund started more primarily as a way of experimenting with a new creative art form. So this is also what makes it interesting. And this is also really gives rise to all kinds of really interesting other kinds of collaborations, like AI researchers and artists, or AI researchers not necessarily on this deep dreaming stuff, but just AI researchers and more social science. We'll come back a bit to that later with some other project we're doing. But for instance, on the I'll share my screen again. On the aspect of, for instance, AI researchers and artists, one of the immediate things I did is, for instance, work together with a Turkish artist, CM Kosemen, which is a very interesting interplay between not just basically taking some of his paintings, which he creates, then running some deep dream algorithms on it, and in some controlled way, but then not just having that as the end product, but actually then taking it back to the drawing board and actually try to create it back to the kind of original piece of art. So this is, for instance, it's the press release we released with that. It was really well received, and it was all over the web. So it's some of these paintings. So I think there are some of these examples as well. So yeah, so for instance, to the left, there is the original painting, and to the right, there is the painting which is created with Deep Dream and afterwards painted up again on a canvas. So it's a kind of interesting interplay of how these two worlds can work together. So that's one of these examples. And then the other example, more from the creative AI as a way to understand neural networks. It's some of the work, for instance, where it's on my KTH webpage. You can find all these things just on my user thing. So this is one of these pages I've put up just to compare different networks with each other, and how on in the final layer, so the final just before the softmax layer, basically how do these different ImageNet classes, how do these look like? And you can see that different networks have still relatively similar ways of visualizing these things, which is interesting from a scientific perspective, that there is this continuity there. But also they have their very specific things, and I'll try to race a bit through this because it's going a bit too slow otherwise for the time. But if you, for instance, take not only the final layer, but you say, okay, if I have this neural network, and I'm really hoping that you can all see this. So if you have a simple neural network and you just have the idea that neural networks are very deep, then that basically in the GoogleNet Inception network, having 22 layers, that means you have really a lot of possibilities to play with these things if you want to visualize what is in it, which makes it problematic but also exciting. But it also means you can take any of these layers, basically almost any, and you can say, okay, I want to visualize what is going on when I put an image in, and backpropagate from that layer. Don't go further, and tell me what you see. So we take some inception for the output layer, and we have Bush, and we say, okay, how would you, do your dreaming? And I won't go too much in the details of Deep Dream. That's a presentation on its own, but you get some image from that. So that's the original, standard deep dreaming, if you will. But if you take that one step further and you want to actually understand how different neurons or different units in this layer, activate, and you say, okay, I want to only use particular. So let's say I only want to use these units, and I can visualize that these units look in a certain way. What would be the effect of just taking unit number 7, 117, 319, and some other unit here? If I just say, I only want these units to work on the original image and give some output, then you get, of course, very different aspects. So this is interesting, and then we can go back to what Samim has to say about it. But this is interesting both from the perspective of creativity, where you can basically go back to these things and you can say, well, these are actually, all of these are different brushes where you can play with all these layers from a creative point of view. And even all these brushes, they themselves, you can even play around with these single units, which all have their individual, like, specific way to interact with this image. So that's from the creative aspect, but then also from the research aspect of neural networks, it really gives you a big insight or at least for me, it has given me a big insight in how these neural networks actually understand in this way vision. So for instance, again, some on my Flickr thing, we can put all these things up. I think it's in the presentation. If you say the same, I only take a very early layer, so I take the edge detectors, then you can actually say that these different units, they have very different ways to visualize these things. So we have particular units who all have their really specific, not only being very beautiful, but also the very specific way to understand vision. And this gives insight for making networks maybe smaller, because you can see very easily that certain units do the same thing, which of course, dropouts often is responsible for. Or you can also just say, okay, if I, take this half away, what happens, and you visualize it again. So yeah, that's some of the interesting aspects I see here, at least.
Yeah, I mean, it's so the single layer unit stuff is extremely fascinating. We'll get to that in a moment again. Jumping a little bit ahead, when we did some commercial work recently with this technology, this became very useful. But maybe just we don't bore you to death with Deep Dream. So before Deep Dream, there was on the text side, on the NLP side, a popular breakthrough with char-RNN, which is an RNN character-based model that generates text. I did a bunch of work there generating TED Talks and things like that, and many people have done similar things. And just after Deep Dream, there was StyleNet. Well, we've as a community now coined it StyleNet, but it's a research paper out of a lab in Germany that basically describes how convolutional neural network can not only capture the image itself and the contents and so forth, but you can actually then extract the stylistic information from an image. And so for the last maybe 10 days since the code developed by an independent developer has hit the net, we've seen again an uprising in many creative minds coming, doing work with this new algorithm. Maybe Rolf can show us some images we've been producing with StyleNet.
Yeah. So there we go again. Yeah. So StyleNet, or a neural network for understanding artistic style, is interesting because it kind of so here's the research article on GitGuide, and this is kind of how the model looks like. So it's created exactly by these guys from a German lab, Gatzis, Ecker, and Betke, and they created basically taking existing convolutional neural networks, in their case VGG Oxford network, and they managed through a quite simple loss function, actually, if you think about it. Very smart, but very simple. Basically separate the stylistic information from the more content. So basically taking earlier edge-like layers and saying, well, this is more related to the actual, content, and combining them with the stylistics, and then being able to transfer back and forth between them. And before we show some of the work we did with this, so this is, for instance, one of the images, and you can take all these different kinds of style images, and you can then say, okay, I only want the style aspect, which is then the later layers in your convolutional neural network, and I want to combine that with the actual content of this original image, and then you get these nice, really great looking, recognizable pictures, still with a very different style. So you kind of jointly train these things like you would normally with image caption models, like from language and vision jointly together. Instead, you would, with the same network, split it out with the loss function, optimizing these things, and then training these different representation jointly. And some of the work with Samim, for instance, did with this is just taking some different kinds of images, and basically, I think we have here taking this video, and there's other people out there, Alex, who, for instance, did work on even creating an entire bot on Twitter where people can send their own pictures with what kind of stylistic request I might have, and then it creates these things.
It's a shame. So the previous one was actually called George W. Bush, just so you get a laugh out of that. Yeah. This one.
So this one, actually.
I think if you go to 6 or 7, you get no, 7 maybe or 8. You'll get one of my favorite ones. Well, this is good. The moon landing with a sketch. Sketches really work well with this. There's apparently a lot of stylistic information. Maybe you go to 8 or 9, you'll find the absolute best one. Well, this is Donald Trump and the Muppets together. You get Donald Muppet or Trump, yeah, whatever. And here, this is practically the best one. This is Osama da Vinci. So you take Osama bin Laden and as a style information, Leonardo da Vinci, and you get this weird thing. Rihanna with a sketch and so forth.
Yeah, and of course you can apply this also to video, and then you get this, you know, quite nice other looking images again. So yeah, that's pretty cool. You can, you know, take Da Vinci and Malevich as the style, and you say, okay, Da Vinci, how would your love child look like with Malevich? And you can do it the other way around, where you take instead you take Malevich, which makes very abstract or Monet-like images, and you get it more like Da Vinci style. So you can imagine that this is, you know, pure machine learning AI stuff, but of course of great interest for you know, creative AI or for creative industry or any of these kind of things. And we're only at the beginning of this. There's so much work which can still be done to develop this further. In my most, you know, interesting aspects for me personally, again, to understand what is it that these neural networks, which often, you know, are termed black boxes, what is it with these neural networks are really doing, and really understand them much better, not only, again, only mathematically, but now also visually. So yeah, back to.
I mean, so I'm gonna pick up from here. So back to our story of a very busy generative summer. So after the work we've been telling you a little bit, and there's been a lot more going on, but you know, this is a good slice. We got approached by many people from the commercial world, the creative industries, with inquiries of doing commercial work with this kind of technology. And it's been fascinating. So we spoke with a lot of people, and we cherry-picked basically the best ones. So in the last 3 weeks or so, we've been working with 2 very high-level big media companies, which we'll name in about a week's time. Apologize, we're under NDA, so to speak. And we've been doing work with them with derivatives of Deep Dream and techniques that, you know, we found along the way. The visual work, and it's been very fascinating because, in a sense, this is very new land. Nobody has, on a production level, production scale, applied any of this technology, and we all know that, you know, doing lab experiments and then scaling that up to production is quite a different story. And so we've had to become creative. On the one hand, we had to boost up the GPUs. So Rolof's been building an absolute dream of a deep learning machine, which is, I guess, a story for, or maybe you can talk about it afterwards a little bit. So you need a lot of GPUs. We're talking 2K imagery or more. And we're talking enormous kind of deadline pressure, creative industry style timelines. And it's been fascinating. And so as a part of that, we early on in these projects we realized that iterating on results will be absolutely key, which is a fascinating notion. It's basically tuning hyperparameters in real time, testing them out, retuning them, and so forth. But so we understood that this is on one level a UI problem, UX problem. And especially if you're trying to do visual work, you need real-time feedback, you need to share parameter settings, and so forth. And so we set out to build specifically for these visual algorithms an UI, which we call the Deep UI, that at the current stage supports Deep Dream and StylesNet animations. And it does all kinds of clever things on the animated side. So we got things like optical flow in there to make frame-to-frame transitions very smooth. There's all kinds of things, and its workflow is key here. So it is designed for teams of multiple people to work generating these images together. And it's in its truest sense, this is a generative systems editor, a UX for generative systems. And I think this is a topic we'll hear a lot more down the line. In a sense, one can imagine a future where Photoshop in 5 years will be full of generative systems. And so the problem becomes, how do you direct them? How do you have the human in the loop there to do an intervention and so forth, to guide it? So it's been very interesting, our project, which has finalized now in the first version, and will have open source released on GitHub quite shortly. Maybe, Roloff, you want to get some words in on this?
Yeah, I mean, for us it's very important to do all these things, even our commercial projects, to kind of release the tools of which we do too, because we really see this as, you know, very useful for science and industry as well, of course, but also as a way to kind of, you know, innovate and develop these things faster, and just, you know, speed up the rate of innovation and research developments with these things, because I think it's something which will become only more and more important. And both of us, as big believers in open source, really feel that this is then also our responsibility to, you know, make sure that it's going in that direction. And that may be also a nice bridge to one of our other projects which we started, which actually came out of the discussions we've had about these things with various people, but also just Samim and I together. So I'll actually, because I've been talking already a lot, I will give it back to Samim to maybe introduce that project.
Yeah, so as Roloff mentioned, we're big believers in open source, and we absolutely think that, especially in the machine learning area, open source has to play a crucial role. And furthermore, it's not just the code we're talking about the data and documentation and so forth. And so there was, maybe in June, July, we really got annoyed by a lot of archive, this site where a lot of pre-publications, scientific pre-publications are happening from deep learning and beyond. And often you have one of these scientific papers, and maybe a week later you'll have a release of the code by an independent researcher on GitHub. And this was a phenomenon we observed for quite a bit, where a research paper comes out, a week goes by, implementation pops up, and we saw it over and over again. And you know, we thought, this is fantastic. This is really a new way of approaching computer science, a very powerful way as well, a very transparent way. So we really fell in love with this new scientific paradigm, in a sense, and thought of ways how we can support this. And this brings us to Project GitKive, gitkive.com, which it proclaims itself to be a site, a portal for collaborative open computer science, which the definition of collaborative open computer science is that you have the research paper, you have the code, you have some links, and you have a discussion, all presented at the same time. And it's a very convenient website, really, where these open source projects that have a research paper and have some links and have a discussion are presented in union. And there's a directory there that can be browsed, and it's fairly fascinating. Maybe we had a really wild ride with this. Maybe, Rudolf, you can elaborate a bit on that ride.
Yeah, well read. I mean, yeah, I mean, yeah, there's many different things we could say about this, but well, next to it just being completely swamped by people who luckily are excited about these things, and our poor, you know, self-funded servers not being able to keep up with the amount of traffic, or barely. So that's a success by itself. But basically, it's a first experiment where we thought, like, okay, if we connect these things together, that's really not only useful, but it's also important in a way that for me personally, I see science as in, you know, developing knowledge and making it reproducible and making your experiments reproducible, cannot be actually science if research is not reproducible. And research is not reproducible if, for computer science, not the code is also released, which is very much different from natural science, social science, where my origin lies actually in. I've been studying, I'm actually an anthropology student, master's, been doing that for 10 years. And there you have literature and you have interviews and you have literature reviews and studies, and all of this is of course open. You can just take out the book and you have your empirical materials. Computer science works a bit different because there's so many nitty-gritty details of algorithms and other kinds of stuff that you can't really say my research is reproducible if you don't release the code as well. So this is one of the missions we kind of don't want to solve, because it's a very big question, but at least want to help people think about these kind of aspects. And these kind of debates are luckily already ongoing for a long time, and we just hope that this will drive it even further for people when you release, when you have an article, to also release the code and put it on GitHub. But we don't want to be with GitHub an extra repetition of things which already work really well. So that's why we decided we just want to be a portal. There is an amazing our archive already there for publishing your articles. You have GitHub for your code. So all we do is just link them up and be a front to those things. So that's kind of what we set out to do there.
Right. So one very pleasant development to unfold from GitHub has been we've been fortunate to get in touch with very interesting people that have this open science, computer science mission statement at heart. And so we've been talking with professors in different universities, we've been talking with people at CERN about this and so forth. And there's a lot happening in the open computer science movement. And I urge you all to get involved philosophically or practically, support the open source, because or even open networks, open image nets, etc., etc. It is a very important cause. We really don't want to head to a future where the underlying data is not accessible, it's not reproducible, science is bottled up, because this would really hinder innovation. And we have great advantages from openness and transparency. So however we can support that cause, we will. That said, so currently one of the more interesting areas of development is that we've been talking with people in biocomputing and the whole kind of bioinformatics space. And there's been significant interest there to start a fork of GitHub to have a specified GitHub-like environment for their own research and so forth, with their own tag space, etc. And so we've been promoting this idea of a federation. Code is open source, go and fork it, put it on your own server, build your own community, but let's make sure these servers can talk with each other. So there's a federated model or a distributed model there. And you're all welcome to join us, look into this. It's all open source. We have a wiki that is quite active. There's interesting voices there. It's a nice community to be part of, and it's been a very pleasant ride so far for us, and I guess for the people as well involved. So maybe this is a good segue, as we're under time pressure, to move to the next major thing, or one of the things we've been doing, I suppose, which is called Ethical Machines, ethicalmachines.com. And so we're big fans of podcasts, Rolf and me both, talking about AI and other topics, and it's a very nice medium to get across conversations. And as we told you in the onset of this presentation, how Rolf and me met was in a Twitter discussion about ethics and machine learning, which is, it's not everybody's topic, but it's an important topic. And so we decided to give this topic a platform to talk with interesting people about it. And so Ethical Machines is a podcast at ethicalmachines.com that discusses particularly these tricky questions that come from generative systems coming of age, and basically a series of conversations talking about humans, machines, and ethics. And its goal is to spark a deeper, better informed debate about the implications of intelligent systems for society and individuals. And there's a lot to debate way beyond these silly Terminator metaphors, or what traditionally the media would hype up. There are very interesting questions that spring up. So we've had 2 episodes so far, about 30 minutes each. The first one was Mark Riedel, a professor that focuses on generative story generation. Very interesting person. We touch on things like generative copyright, what happens when journalism becomes, let's say, augmented by generative systems, and these kind of finer points in the whole debate. Second one was with Jack Clark of Bloomberg, where he brings, in a fairly detailed discussion, brings up the notion of a neural network artist. He looks at what the implications are when high-speed trading firms on the stock exchange start to use deep neural networks. So interesting topics, really, and a conversation is a great vehicle for that. And so maybe, Roloff, you want to add a note here?
Yeah, I think we're wrapping up here for some, if you guys have some questions. But yeah, so Ethical Machines, first of all, is born because of Sami and I both like Talking Machines, another really great podcast, which needs actually everybody's support to go into the second season. So they have a Kickstarter, and exactly they're trying to go further with actually not only taking computer science, but also some natural science interview and stuff in there. So because we were so much fascinated and fans of this format, which they kind of use, we kind of made a little switch with Ethical Machines. So it's not a criticism at all. It's actually the opposite. So just to make that clear. Yeah. So
Right.
I think, Sami, maybe you want to go back to the future.
Yeah,
what the future holds.
Exactly. So to round up our discussion here tonight, we'll give you, that's a premiere for you guys. We'll give you an outlook of what we're planning. One of the bigger things we're planning next. So we're in the process at the moment of forming a new machine learning team that bridges between machine learning and the creative industries. And this is not a startup at all. We have our own, critical views of that world at times. There's good and bad.
We have our own background in that world. So.
And also our own background. But we just call this a team and a network for now. We'll see where it goes. We're 100% focused on building artificial experiences, hence the name artificialexperience.com. And so mainly what that breaks down is we're applying machine learning techniques to creative industries. And there's, creative industries is a very large field. We're talking anything from architecture, design, to fashion, to art in a more traditional sense, painting and so forth. It's a very wide spectrum that, if you think about it, is one of the last very big human endeavors or industries that has not been fundamentally touched by machine learning, even though the low-hanging fruit potential here is very large, as lots of our experiments have probed basically lately. And so I apologize, this is top secret for now, but we'll give you a glimpse. There will be a big unveiling soon with clients we'll be working with that come with the unveil, and some more kind of general concept or thesis behind why and how the creative industries can interface with machine learning, where the fun and where the profit is here, because there's a lot of low-hanging fruit here, and it's fascinating work. So maybe, I don't know, if all of you want to dig deeper into this, or shall we leave it at a cliffhanger?
No, I think we're kind of out of time. We don't want to leave you guys the whole evening in there. So it was fun being at the meetup. Yeah, also nice to mention, we're actually where I'm now at in Stockholm. I'm also organizer of the Deep Learning Meetup. So if you're ever around in Stockholm, shoot me a mail, and people are very much welcome to give a talk there.
All right, thank you so much.
All right, thank you, guys. So, Sami, can you hear me well?
Yeah.
Okay. Well, I think I can say for a lot of us here that we feel unworthy talking to you because my summer used to be something where I thought I was doing a lot of things, but now I'm looking at you, what you guys did, and I'm like thinking, well, hello, I haven't done anything. So congratulations on all these things that you did this summer. Probably 2015 should be called Samim and Rolov's Excellent Summer from now on. I'm going to ask the crowd to see if there are questions on the different topics you had. Maybe I have one. Can you tell us more about the traffic you got on geekive.com?
Right. I mean, so we hit the front page of Hacker News. Maybe there's a fun story. The night before we had a deadline and we were working late. So in the morning I woke up maybe at 7 or 8 with a hangover, went to the computer, and it hit the front page of Hacker News. And all our servers were completely destroyed basically in about 10 minutes. And so I ran to the laptop, booted up more instances on Amazon, and tried to somehow get load balancing working and then these kind of DevOps pain things. And it took about 15 minutes, and those servers went down. And that was the whole day. I mean, that was just the whole bloody day. It was disgusting and beautiful at the same time. And it's been fairly good. So I mean, that was the giant peak, and there was hundreds of thousands of people in one day, and it's stabilized now where we have a nice core community. So I judge it more by submissions, which is maybe 15, 20 a week at the moment, which is fairly nice to know that there's so much great open source plus research paper work going on. It's fantastic, really.
Cool. Est-ce qu'il y a une autre question dans la salle? Vous avez vu à peu près toutes les choses dont il nous a parlé, dont ils nous ont parlé. Il y a une question? Well, let me have another question. For the creatives, how did they figure out that you were the type of people who were interested in this? Is it through the Obama RNN thing that they got to figure out that you were trying to do something else with Tynet and Deep Dreams, or was it some other means of getting in touch with you?
Rolov?
Yeah, I can say, well, having millions of people checking your YouTube clip, which you released for fun, was kind of enough to get shitloads of emails of interested parties. Yeah, so that was helpful, and then it was just a way of taking a close look at the more interested parties to see which were serious or which were interesting. Yeah, and majority of that was also more like, okay, how can I do this myself? And the code was there, and just helping people get this stuff working, and pointing them to the GitHub repository. But then there were some bigger parties. I mean, there was way too much parties who wanted to also get us involved in their project that we ever could and still can in a whole year. Like movie directors from record labels, music record labels to whatever you can think of and in between.
Not movie directors of movies, movie directors of music videos, right?
Of both, also music directors of movies.
Everything, yeah. It's the interesting thing really is, I think one of the reasons that we were visible to these people, obviously we did some research of our own, we've been publishing quite actively, but I think more importantly as well, we've been friendly with people explaining things. And I think this is important, and you don't see this across the industry, unfortunately, where if people have questions, answer them, help them out. That's the whole point of these popular AI movements, is to have mass education. This is an opportunity for mass education about machine learning, and so me, for one, I've been every question I got, I took the time and I answer people, and journalists the same, right? And it's all about building these relationships.
Cool. Y a-t-il une autre question? Vas-y. Oui. GitHub. Yeah. Can you load up the gitarchive.com interface? Can you share the screen?
I don't know if you can maybe share your screen.
Yeah, so the GitHub is here, so we already have immediately the neural algorithm or artistic stuff. So this is just gitxiv.com, and what you get if you go there is basically just a list of different items, different research papers, generally with code implementations and ways to comment and discuss. And right now, it's not the nicest way. Of course, it's a project on development. It's on GitHub, so anybody is able to help out with this as well. So just different categories, like let's say I want to have deep learning. So it's very much biased towards deep learning at the moment, because that's where both Samim and I are most active and most comfortable with. But there is some bioinformatics in there and some other general mathematics and other kinds of stuff.
One of these pages one more time. Detail page is kind of where the meets are.
Yeah, for instance, recurrent models of visual attention. So that's one of the NIPS papers. So you go here to archive. It's not always an archive. It's more a nice placeholder that we would prefer to be archived, but it can be kind of anywhere out there as long as it's not behind the paywall. And then GitHub, which again can be sometimes even zip files on academic websites. And then there's some dependencies, some links, some comments, and basically anybody can post stuff. You post, and then you can create your entire own thing. And we're very happy to receive more posts of interesting projects. So that's GitHub. And then of course there's the general. You can just go to my nick Graphific, and then you see different projects there. But this is the deep learning implementation on video, and then there's the same of Samim. And we're now working towards an implementation, which actually I can show you a short. Why not?
Yeah, sure.
Of kind of fusing all of this together in a more visual editor. So we have thumbnails. It's not yet an actual video editor, as with how a normal one would like, but it's quite close already. We can iterate really fast. We have all kinds of settings. We have some of my down here, for instance, the single units, like how many single units, specific units, I can specify I want to fire on, and all kinds of other general settings, and start rendering on frames, and off you go. And then this is the machine we've built for all this kind of stuff. So because in Europe, of course, DevBox from NVIDIA and stuff is not available. Actually, I've built my own machine there for also my own PhD research. And it works pretty well, and there's a blog post upcoming whenever I can find the time to do so.
Yeah.
Yeah.
Yeah, that will be the subject of a different talk.
Yeah.
Est-ce qu'il y a une autre question? Is there another question? Oui. Vas-y, dis-le en anglais, je parle. Yeah.
Do you think it's possible to have a link to the networking of neural nets who are not working on communication, because daydreaming is about images, but maybe the insights can be useful for other kind of neural nets, for instance, to NLP. So do you think the data used in image and daydreaming could be used for other kind of neural nets?
So if I'm summarizing the question, and you tell me if I do well, StarNet and Deep Dreams have been applied to images, and you've been essentially mucking around with some of the layers and everything. The question is there a similar type of insight for NLP type of deep learning type of algorithm? I'm thinking yes, because of this Obama RNN that you had done. Yeah. So part of the answer is already yes from the previous meetup. We had Samim talk about this RNN that he had essentially implemented on Obama's speeches and basically had him at the RNN generate a speech that looked like one of Obama. Okay, but have you done something on top of this RNN Obama since then?
I mean, you know, this is interesting because the RNN stuff is not directed enough at the moment. So one of the things we've seen this summer in the NLP space are these question answering systems to come really full force back, coming from Facebook and the likes, Barbie, whatever they're called. And these are interesting things because now you can train one of these networks with pairs, basically, and you can start to ask these questions. And so these are, it's quite interesting towards what the MIT in the early 2000s called a remembrance machine, which the notion is a machine that reads all your communication, everything you read, everything basically, total surveillance. And then in the current context, it knows your context, starts to present your memory back at you. So you can start to write, you know, 10x faster. You can start to summarize stuff with your own past memory, helping you and so forth. And so we're slowly moving towards these ideas, but slowly. And I think NLP is an interesting case. The question answering stuff, definitely look at that. It's fascinating.
So question and answer.
Yeah, if I can say very, very shortly on that. The 23rd of September, there will be actually the Stockholm Deep Learning Meetup focusing directly on both vision and the RN, but more technically on exactly these kind of networks, how these can be used for creative AI. So it will be live streamed, so there will be more on these kind of types of questions there as well.
Okay, yeah, or we can be in Stockholm on September 23rd, right?
But maybe I'll add one experiment I've been doing just as a fun afternoon experiment. So I'm fascinated by the idea of applying StyleNet to audio, which, you know, is the possibility, at least in a sci-fi perspective, is absolutely amazing. Being able to say apply the stylistic information of classical music to a death metal song. So I've been doing tests where you, very simplified, you get the spectrograph of music, you create an image, and you do that 1,000,000 times, you train a network on these images, which de facto are just encoded sounds, and then you run something like Deep Dream or StyleNet on top. Now, it sounds good in theory. In practice, you have all kinds of problems representing music in images because of phases and so forth. But there's developments there. So the main developer behind the Rosa jumped on it. He's developing a new method of capturing audio in images. And you can imagine what happens next. If there is a breakthrough, we'll get Deep Dream and Deep Style or StyleNet, whatever you want to call it, on different media. And this will be very interesting. Wait and see. I'll give it 8 months from now.
8 months. Okay, so that's a date then. Est-ce qu'il y a une autre question?
La dernière.
La dernière? Allez, une petite question?
Non. Ok.
Non. Okay. Thank you, Samir.
Thank you.
Thank you, Roloff.
Thank you.
If you can put yourself on mute, you can follow the continuing, but we're going to be in French, so it may not be as interesting. All right. Thanks, Samir. Thanks, Roloff.
Thank you.
Ronde? Où es-tu? On va essayer de faire très très vite. Enfin, pas pour Ronde, pour les autres. Non, ça va être des tout petits pitchs en fait.
Des intros.
N'est-ce pas? Ouais, voilà, c'est ça en fait. Maintenant, on commence à avoir chaud, on a soif, on a déjà bu toute la bouteille.
Il en reste une, il doit.
Non, je vais brancher mon PC parce que j'ai un soft dessus.
Bien sûr.
Oui,
De toute façon, c'est fini, j'espère.
ouais.
Juste le câble, hein, c'est tout. À la télé. Super. Hop. Alors. Bon.
Français, anglais?
Comme tu veux.
En français?
Comme tu veux.
D'accord. Tout le monde parle français, quoi.
Non, il y a quelques...
Okay, so English.
Je peux parler fort.
D'accord. Attends, je vais me mettre de l'autre côté.
Qu'est-ce que c'est ça? C'est peut-être négocié à moi, excuse-moi.
Non?
Ok, c'est bon?
Allez, quoi?
Qu'est-ce que c'est ce bordel? Attends, je pense que ça fonctionne.
Voilà. C'est bon?
Ouais.
Ok.
Donc, juste pour expliquer un petit peu où vous êtes. Donc, là, on est dans de nouveaux bureaux. Pas cette salle-là, c'est la cafétéria. Donc, l'immeuble par lequel vous êtes entré. Sorry, the building in which you came in. So, just to give a very quick idea about what the company does, we created a company a couple of years ago because we wanted to do data science and machine learning applied to everyday problems. So we felt that it made no sense that so many people knew how to use these techniques and still were applying it to basically useless problems. I mean, from a social perspective. So we did stuff like predict crime, predict parking spots in streets, predict car accidents. And eventually we started thinking more long-term about what's happening in the world today with all of those connected devices coming to market. If you predict this stuff in 10 years, you realize that there's going to be 100 billion connected devices. And each of these devices right now is actually very, very intrusive. Because at home, for example, in the phone, it brings on both my phone and my computer. The reason this happens is because my phone and my computer are not able to figure out which one that they should be interrupting me on. So by default, it just goes to one way. Or if you're in a meeting with someone on a date, you receive push notifications for stuff which are clearly relevant. I mean, if in your calendar you have a meeting and you're at the location of the meeting, why is your phone still sending you notifications from Facebook? It makes no sense in that context. And this problem is something called context awareness. It's something that's been around for years and years, but only recently doable. And you've seen it in stuff like Google Now, for example, it's trying to predict based on context stuff you want to see, or the Nest thermostat that learns when you come home so that it can adapt directly. So this whole domain is basically machine learning based. So we figured this out. We're like, well, what if we use all of that technology about modeling what happens in the real world and put one of those contextual intelligence in each device, each connected device in the future? Then perhaps they're going to be able to adapt to us, and eventually we won't even need to interact with them. And this is kind of the big idea behind the company, is that in 10-year time, we don't want people to even notice technology anymore. We want it to be so smart and integrated in our lives that we just don't care. Just as you don't care about electricity anymore, you shouldn't care about the connected device. This is how we see things. So that's in 10 years. So in the meantime, what we did is we decided to focus on one device in particular, which is just absolutely terrible to use at the moment, which is the smartphone. Just to show a little bit the kind of stuff we're doing at the moment. Go straight on phone. Okay. So imagine you and I have been chatting and we want to go somewhere. The way that you would basically go to a meeting is you open a calendar, probably look up for the meeting somewhere, which I actually don't know what it is right now. Well, it's not even easy to find. Then you probably look up the address, open Google Maps, and so forth. So we thought this is kind of stupid, right? So why not aggregate all the data coming from all those different sources and make it accessible directly in Google Maps, Uber, and all those apps which require locations and inputs? So we did a very simple thing, which is a keyboard extension, which basically goes and figures out what stuff you might want to do. If you just click on it, boom, there you go. That's it. No need to go and look for it anywhere else. Essentially, we're centralizing all that data in there. And we're not just doing it in calendar, obviously. We're doing some more fancy stuff, like analyzing places you go to usually. So we look at your location trace, figure out places you stopped, even though you might be walking in a building, but figure out you're in the building. Learn when you go into the building, what kind of building that might be, and so on and so forth.
We also do some other stuff with the NLP at the moment. For instance, let's assume that you and I have been chatting, and I'm telling you, meet me at that place. So you see that actually the NLP on the Apple thing failed pretty miserably in this one. So it thinks the street is called 207 du Faubourg Saint, which doesn't really help. So the only way I could actually go to the address is if I copy the entire text, then probably paste it somewhere in Google Maps, try to select the little thing, erase. I mean, you know what it is, right? But we just figure, well, we're going to intercept that. We're going to do some very simple name entity recognition stuff on that to see there is an address and directly make it available. So this is the thing you see here. If you click on it, you can see the actual address. So not only does it work better than Apple's one, it also just removes all of the padded text that there is around it. So that's pretty cool. It's on iOS. We've got a bunch of other stuff coming. We have an app, we have a widget. But still, it's sort of, one step too much. I mean, I don't know, I feel. It's like, it's very convenient and stuff, but it's not as magical as what you can do on Android. So I'm going to show you something that we're doing on Android, which is, I mean, I'm pretty excited. I don't think anybody has seen that yet. That's not the office. Anyway, so on Android, you can go much deeper into the operating system. The reason why we do this on iOS is because there is no other way we can do it. So we try to build those small extensions by leveraging whatever the platform offers us as a way to get it. On Android, we've decided to really go deeper. So you see there is no interface. Yeah, actually, there's no screen. Great. Okay. So on Android, as you can see, we actually don't really have an interface. What we do instead is, actually do a few things. The first thing we do is we monitor your screen. So let's imagine that you and I are chatting, okay, and I'm telling you to meet me at that place. So typically, once again, what you do is probably copy the place, switch back to your home, find Google Maps, wherever that is, open it, and so on. With the usual thing, switching between internets. We think this is sort of like useless. So instead, you read this screen in real time, do some NLP, and if you swipe up, you see now it automatically detected the place, completed the actual address, and figured out it's an address, and that therefore the apps you have on your phone, which is an address are here. So if you click on City Mapper now, it launches City Mapper with the address pre-filled. So you see how much more convenient that is than just going around. But of course, it doesn't really stop there. Let's assume that we talked, a few hours ago, right? So I haven't done anything here. See, there is no interface, there is nothing. I haven't done any gesture. Let's say that an hour later, I want to go and meet you. I open Google Maps. And this time, if I swipe up, we're able to figure out that this is a location app. And therefore, we're not supposed to read the screen. We're supposed to be giving it data to inject directly. So here, not only do you find, again, the 12 that point, which we found earlier, you also have the other addresses, which I only saw on my text message. I never interacted with it, I just saw it. And if you click it, then it just injects it, and there you go. Right? And so this kind of intelligence, which is based not just on the context of what you're doing in your life, but also on the context in which you're inside your phone, is how interfaces should be. It makes no sense in 2015 with the technology we've got, the number of apps we could be using to still be juggling around and remembering the location of an app inside a phone with potentially 12 screens and 100 folders full of different icons. It just doesn't scale that well. So anyway, so what I just showed you here is pretty much as good as it gets in terms of many different kind of algorithms. So it's not just machine learning, we use all kind of different data science stuff. It's pretty good. And one very important thing, it runs 100% on the phone. There is no data whatsoever being sent to a server. Everything I just showed you here on Android and iPhone is a result of algorithms running locally on the phone. And this is how we can actually look people in the eye and say, yeah, give us access to everything because we actually don't have the data. It stays right there on your phone, and that's it. So that was it for a bit some of the stuff we do. We have a lot of things in the pipeline. The team is growing. There's about 20 people now. We're going to double in size in the next year. I think that it's going to make us one of the largest data science companies in Paris. We've raised quite a bit of money from American investors. and remain a French company. So this is also something pretty new, right? We insisted that we wanted to be a French company, even though our investors are all based in America.
When I was talking to you earlier, and we were looking for the room, you told me that you had some plans for this specific room. Have you thought about it? And do you have plans you want to share with us?
What do you mean plans?
I don't know. Well, maybe we should take this offline.
So it's not really something official or anything, but the point about having this space is that we want this building essentially to become really sort of a place people can hang out and talk about machine learning and data science. And I was, for many reasons, probably the IDPC here is going to kill me for saying that, but we actually do want this space to be more open. So, you know, if you want to hang out, if you want to have lunch with us, if you want to just work a little bit, we'd like this place to be like that. But only for people with machine learning. Look, there's already 120 people, so we can't
to get the conversation going, who is working with you in this? And it's going to be essentially eating around. And so, can you present yourself?
So I'm one of the founders of the CTO of data statistics. So we started the company for 2 years and a half ago. And the CTO is so Gab is your new CEO. I'm the one who's going to kill Rand for saying what he said. But we worked it out. You'll have to go through me.
Okay, so Gab is the go-to person. Anybody else who wants to? Yeah. Okay. And who else should we be talking to?
So across, I joined the 1 year ago, started the village, I'm one of the scientists as well in the company, and just want to say that the company is great.
Yes, Klaus, sure. Yeah, the company is great. All right. Are there any questions for Rand right now? Est-ce qu'il y a des questions pour vous?
Est-ce que tout le monde a compris l'annonce déjà?
Amine.
Quelle annonce?
Qu'est-ce que vous vouliez dire? Le fait que ici.
Ah, bah, c'est pas une annonce. Enfin, si ça vous intéresse, on participe pas.
Déjà, le fait que vous soyez ici.
Ah oui, c'est vrai.
Et le fait que vous.
On a emménagé la semaine dernière. That's why it's empty. Just moved in. So on the phones, we use whatever the phone provides us. So on iOS, we use Swift. We do everything reactive as well. So for people who like software engineering, it's pretty advanced as well. On Android, we do a language called Kotlin, which is a functional language for Android, which is pretty nice using RS Java. On data science side, we don't have really any dogma. It's whatever you want, because at the end of the day, if it's implemented on the device, it's going to be recoded in Swift or Kotlin anyway.
On Android, you use Kotlin?
Yeah.
Not
So I love Scout. Personally, like it's really one of my favorite languages ever. It's just that, practically speaking, the binaries are still a bit big because the library has to import.
But you don't use a lot.
I mean,
yeah. So you got all of your money from investors, but so you have clients today, and how do you get some money?
So
do you sell services, products?
No, we started by being kind of an innovation lab and get quite a bit of money with big companies. But now that we're focusing on our own products, we're basically not making anything. So we're just spending. And it was I'm saying it because it was a bit weird for me as well, going from making money to on purpose not making any. But you actually need to do that because everything I just showed you here, these are like new kind of concepts of both design and machine learning, and we don't really know what this will look like in a year. So the idea at first is to really focus on building good models, building good products, and once people use them all the time, then we can figure out the monetization. One thing for sure, though, is that we're never going to be able to monetize with the data because we don't have it.
in that
Your investors, how do they see monetization?
They've told us that there's absolutely no point spending €1 on thinking about that. Very American.
Are there any type of specific farms that are very hard for you to take a step back, that you think would need additional great power, gray matter, to essentially take a step back? Are there specific farms that you know are very far from you, or are there a bunch of small farms that you think you're going to be able to tackle?
So what we discovered when we started working on these kind of interfaces is that every time you solve one problem, you realize that you need to solve another one for the thing to actually work. So we started from analyzing location, single processing, and a lot of classification, and now a lot of NLP. If I had to pick one problem that really is huge for us, it definitely be NLP. So we've got a few people working on that. Someone just started working on language understanding, natural language understanding. So using some something like that. It's not something that's implemented yet. We actually want to hire a lot of people on the NER stuff, so in entity recognition. So here I showed the example of addresses, but you could be chatting about a movie. If you swipe up, we want to figure out it's a movie and link you to IMDb and so on and so forth. So we have a huge chunk on NLP, which we're just getting started on, which definitely would love at least to have the discussion with.
You use open source libraries in NLP, like the Stanford or NLP or other types?
So we have that constraint that it has to run on the phone.
Yes. You have to rewrite everything.
Exactly. Well, I mean, we don't have to, because we get prototype models offline, right? But then once it's implemented, there's always a trade-off. If your dictionaries are huge and everything, you need to sort that as well. So there's always this engineering sort of bottleneck that we need to do. But I think we think at least that that's the minimum we can do to guarantee privacy. It's our problem to fix that, right? Not the users.
But it does limit the scope of what you can do.
Sure now. So
I don't know.
Louder.
Yeah, do you think to publish
So yeah, very likely. Probably more and more going forward, as well as open source. What's important to understand, and so all of us in the company come from a pretty much research background, data scientists. And when you do a PhD or work in academia, you're not really used to those, let's say, those business problems you need to solve. And for us, when we build something new, we have three choices. We can publish it and open source it, we can keep it a secret internally, or we can write a patent. The reason why we write patent is not to sue people. It's actually to make sure we can keep using it. So as it turns out, if, let's say, Google is working the same stuff as us and they patent, we're fucked. We can't use our own technology. And that's something you can prevent by being proactive. But 100%, everything we do eventually, we'd like people to do that. It's just the time frame might be 4 years instead of 6 months. Yes. So the idea of Snips is that it's not an app or a keyword engine. It's really just a layer on top of any operating system that is making your life easier. So right now we have Snips for iOS, Snips for Android, but of course we're going to do Snips for OS X, for Mac, for Windows, for your car, for your fridge, for any object. Yeah, actually, I met with a bunch of people at Firefox. Probably, it's again a question of bandwidth. If you have 20 people, even 40 in a year working on something, you need to prioritize based on needs it the most. But Firefox is good. It's very open and everything. It's pretty.
A few months ago, I used on the website that you aim at understanding institutes and managing this.
A year ago, like a year and a half.
Yeah, maybe.
Yes. So it's the same thing. When you talk about context, one piece of context, one layer is the environment around you. So context, you have 4 different layers. You've got the devices. So devices need to know about each other, right? So your phone and computer need to know about each other. You've got a social layer. So it's important to know that you're in this room with these people, right? Then there is the individual layer. who you are, what you're currently doing, and then you've got the environmental layer, which is everything around you. So it turns out we started by modeling the environment, and then we went down to modeling the user, right? But everything comes into play. It's important to know that it's raining. It's important to know that there's no more metro. It's important to know that there is an accident and you should go out of the way. All these information just make the experience better.
Question about the phone market. A lot of the application of a lot of things that you present are very computationally intensive. That is very limiting in terms of what you can do with your phone, and not all phones can actually do that. What part of the phone market can you actually address?
Well, definitely not phones from more than 5 years ago. It's not that much. It's actually computationally speaking. So most modern phones are okay. And I think by the time we capture a big enough market that this is an issue, and we will have a vote as well. Also, there's stuff we haven't started looking at, but it could help using the GPUs. Use Metal and iOS. I mean, you can access those things, right? And I know there are a few people doing deep learning on the mobile GPUs as well. So all of these things are essentially stuff we want to try. And it's the reason why we're building such a big team. We don't need 40 people to do that.
So it's not basically it's not an issue.
I mean, yeah.
Yes. You don't need the latest phone. This works on foreclosed.
No. I mean, this is not meant to be something that 100 million people will use it for something, right? This is not like some viral gimmick or something. This is fundamental, low-level interaction sort of thinking. And this is why the only people competing are Google, now and Tap, which is very similar to the kind of stuff we're doing. Apple with Proactive, they're launching a moment. They're all working on these things because this is where we're going with mobile. So if it's good enough for them, I guess it's good enough.
If you don't collect any different data, how do you affect the volume of data?
So that's a challenge. So we do collect data for ourselves, for the team, right? We're planning on enabling also users to opt in if they want to. Right? So they could tell us, okay, well, I like you guys, I trust you guys. Here's my data, play with it. And most importantly, we make sure that our models actually don't need that much data. So if you're looking for the big data, that's not really what we do. Actually, a lot of the constraints we have is working with very sparse data. So it's a different kind of problem. And very often machine learning, like raw machine learning, wouldn't work. I mean, for NLP, you could train offline and everything. But for personal data, it might not work. And this is why I'm saying we don't just do machine learning. The reality is we're doing data science, of which machine learning is one type of model.
Do you plan to let us get involved by perhaps on the market? Okay, I want to share my data. Can I use you right now and try to figure out how it is useful for me? Then you get my data and use it for. Yeah.
That's the idea of the beta test. Although we didn't really plan on getting that data from beta tester. So right now on iOS, for example, we have 1,000 people trying out the keyboard. We're collecting a lot of feedback. Once again, we don't pretend like we have the answers. We don't know what the right product should look like. All we know is that we can do some stuff which kind of makes sense, and now we want to give it to people and just work with them to figure it out. And on Android, by all means, and you can do so many things. If anybody has ideas, we definitely take them. Like the ideas.
Une dernière question pour your competitor in your field?
Yeah, Google and Apple. Yahoo as well has Aviate. Microsoft just released a thing for Android which does the kind of down tap feature. Basically every big company. I mean, in startups in general, we don't have that many startups doing the kind of stuff we do. And we're definitely the largest one in our space as a startup. And we're French.
What's your edge versus Google and Apple?
So this is always a very complicated question. I can give you the official response, right? The reality is that this isn't just an engineering or one-way problem, right? We're talking here about inventing something radically different from what we have. And like everything that is really sort of pioneering, it's not because you have $100 billion to put at it that you're going to have an answer. And sometimes actually the hungry small guys get an answer because we don't have a choice. You know, Google can fail, we can just acquire a company that succeeds. If we fail, it's 40 people that basically don't have a problem to solve, or at least not this one. So it's important for us to nail that. So I think this is the first big advantage. The second one is we're bringing research. And this is what I was talking about, the time frame of not publishing everything right now, because some of the stuff we do, Google doesn't do yet. And some of the stuff they do, we don't do. Right? Everybody has a different technology. And finally, I think the privacy thing is really important. Google sort of assumes that because they already have all your data, it's okay for them to screen your screen and do that kind of stuff. I don't think that's right. You know, I think that going forward, it just makes no sense whatsoever to basically tell a user, you know, that you need access to his data on a centralized server, cross with everything else, that he has no rights. It just doesn't make sense. So I'm hoping that someday people wake up to that and realize that there are a few people trying to do the right thing and build a good product, of course. I mean, that's kind of it.
On remercie Rand. Donc, trois petites interventions. Amine, tu peux faire vite. Voilà. Christophe, viens. Christophe est là. Non, c'était Christophe. Christophe est là. Et Christophe, Maxime. Alors, pas Christophe. Si, Christophe est là. On va essayer de faire vite. Ouais. Le premier qui va. On fait très vite et on va manger, on va voir.
On démarre alors. Vas-y, on peut s'égourdir les jambes.
Comment
French Data.
Qu'est-ce que c'est? En fait, c'est parti sur qui circule sur Twitter, qui connaît French Data.
Il y a un petit peu de marge de progression.
Il y a 98 personnes qui font des 5 minutes. 5 minutes qui circulent sur Twitter. C'est né à, si on compte en temps addition 3, je crois, du premier Meetup chez Yahoo. C'est à peu près il y a 2 ans. Ça a vu passer des levées de fonds, ça a vu passer la création de postes, ça a vu passer des choses politiques qui sont passées, qui sont passées en plein de choses. C'était un fil Twitter et il y a deux personnes, donc Jérémy qui est là, qui nous a rejoint pour faire le site web. Donc très rapidement, je laisse la parole pour vous expliquer ce que c'est, après vous allez voir le web.
C'est ça, donc en fait, on a contacté Christophe avec Stéphane, dans le but de compléter le Twitter qui entretenait. Donc finalement, nous, en fait, on fait un peu comme Slips, finalement, on essaie de vous simplifier la vie. On essaye d'agréger en gros l'information data dans un seul et même site. Donc finalement, tout ça, on a pensé à 3 composantes principales. Une première, ce serait une composante actualité, dans laquelle vous pouvez retrouver toutes les actus principales en France. Donc vous pouvez voir certains billets, donc pour le moment il n'y en a pas énormément, mais à droite vous pouvez voir le Twitter, donc toutes les informations en live. Deuxième composante de mention qui était intéressante pour agréger l'information data en France, c'est de faire un agenda pour rassembler tous les événements data en France. Donc quand je parle d'événements data, on a commencé par agréger une grande partie des Meetup data en France. Et comme vous pouvez voir ici, en septembre, il est assez rempli. Mais très prochainement, on compte aussi ajouter les débuts de concours en ligne. Donc, je veux parler de datascience.net et Kaggle principalement. donc ajouter les débuts de concours et aussi les dates à partir desquelles on ne peut plus s'inscrire. Je pense que c'était assez intéressant.
Est-ce que tu peux ajouter aussi tous les trucs européens et les pays France ou des mentions de data scientists? Donc, les pays commencent à s'y mettre. On commence à avoir une sorte de vague au niveau européen sur tout ce qui est SNE, tout ça. Ce sont des échéances très beaucoup. C'est bien les équipes de connaître.
D'accord, de toute façon, on est ouvert à toute suggestion. Si vous avez, une suggestion, une remarque, vous pouvez nous contacter via le site, via Paris. Et finalement, une dernière partie, une partie job. Donc, ici, en fait, on a filtré les offres d'emploi de deux profils principaux, les data scientists et data engineers. Et donc, vous pouvez retrouver ici les principales qu'on a trouvées sur différents sites web et qu'on a filtrées.
C'est classé comment?
C'est classé
chronologique.
Pas en chronologique pour l'instant. Et vous avez différents tags pour si vous êtes intéressé par exemple.
C'est fait à la main, il y a un mec qui fait ça.
Alors c'est nous qui avons fait à la main ça.
Et les recruteurs peuvent déposer en ligne. On a certains recruteurs qui commencent à déposer en ligne. La problématique du vote que j'ai eu en fait avec le LinkedIn, on a à peu près 800 personnes inscrites sur Paris. C'est vraiment en fait que tu as des gens qui ne savent pas lire le français, qui ne savent pas lire l'anglais en fait, et qui te balancent en fait tout ce qu'il y a un truc qui a détail dessus. Ça peut être tout n'importe quoi. À partir du moment où il y a des data sur la description du truc, ils balancent le truc et le font sur tout le monde. C'est modéré. Voilà. Donc nous on le modère aussi, ça prend un peu de temps pour que ça prenne, mais la force c'est une initiative de l'université. Je voudrais gagner les mots. Les mots peut-être là, je pense que
non. C'est une bonne idée.
La date de démarrage, la date de fin.
Ouais.
C'est ADS qui a réuni les deux, qui est très sonné, qui est super.
Si tu veux regarder la centrale, en fait, avec l'aide de
il y a Télécom Caractère qui a sorti aussi un mois qui doit démarrer très bientôt. Ça permet aussi d'avoir un
D'accord.
Un best place, dans ce cas-là, un best place to work de data, genre glace d'or, une sorte de classement avec des boîtes de data. Tu vois ce que je veux dire? Glace d'or, c'est l'innovation des entreprises. Ah oui, ça permet de l'enrichir.
C'est bon, ça marche.
Merci. Très bien. Tu parleras des malades. Et les blogs, on peut poster quelque chose sur le blog? Comment ça se passe pour le blog?
Non, pour l'instant, non. Vous pouvez soumettre des idées, mais c'est nous qui pensons vraiment.
D'accord. Merci. Je peux commencer aussi?
Ouais. Alors, je voulais vous annoncer que la session d'accélération de Startup 42 va bientôt démarrer. Donc, Startup 42, c'est un accélérateur qui accompagne 7 startups pendant 4 mois. Et on a une grosse impédance pour les startups qui basent leur avantage compétitif sur une innovation technologique et qui ont des équipes qui sont principalement constituées d'ingénieurs. Donc, si vous êtes intéressé, n'hésitez pas à aller sur startup42.org, il y aura un gros bouton Apply. C'est 4 mois avec 6 autres startups où on vous offre du coworking, un espace de coworking, du mentorat, dont Randindi en fait partie, de l'expertise technique de l'école EPITA, de challenger sur vos problématiques, des avantages auprès de partenaires, donc crédit Google, des choses comme ça, et enfin de la communication. Et voilà, donc c'est un environnement où vous allez pouvoir apprendre une méthodologie et avoir des feedbacks d'experts et de mentors qui vont pouvoir vous accompagner. Donc n'hésitez pas à aller sur startup42.org et vous inscrire, vous avez jusqu'au 30 septembre et la session commence le 12 octobre.
On connaît combien?
On prend 0, en fait c'est gratuit et on ne prend pas de permis.
Dans 4 mois, En 4 mois, tu travailles pour nous.
C'est ça, exactement. Et on a quel intérêt. Alors en fait, on est sponsorisé par l'État en grande partie et par 4 autres sponsors privés. Et l'intérêt, c'est de donner plus de choses aux startups, de les accompagner plus. Et voilà, donc là, on a les listes des mentors. Voilà, c'est juste d'aider encore plus les startups, de briser les barrières à l'entrée pour elles, pour l'accélération, pour accéder à l'accélération. Et on est vraiment orienté pour les profils ingénieurs, on est bien meilleur pour les accompagner, pour les orienter vers la réussite. Juste un petit focus, on a accéléré pour info, Collective Thinking, je vais vous parler, Zico, Dreamquark et enfin Bastien. On est là, c'est la 6e saison du marque. Ça fait 36 startups accélérées, 31 encore en activité. Collectivement, elles ont levé 5,5 millions d'euros en financement public et privé. Et c'est très important aussi pour nous, elles ont fait une centaine d'emplois.
Question pour Maxime?
Je suis disposé si jamais.
Ouais. Vous pouvez parler avec lui quand on rentrera. Merci Maxime.
Une autre info aussi que je pourrais rajouter juste à ça. Alors, j'ai besoin de 2 minutes de votre attention. Donc, on va parler de comment le machine learning peut aider à servir une cause écologique. Donc, en fait, le but, en fait, c'est un challenge qui est sponsorisé sur Kaggle. Donc, pourquoi le challenge a été créé? En fait, c'est pour sauver les espèces des right whales, donc c'est 3 types de baleines blanches. Actuellement, comment est-ce que les chercheurs qui travaillent à la protection de cette species fonctionnent? Ils récupèrent des données de balayage hélicoptère, c'est uploadé sur un site web, et puis il faut que la personne soit une experte. Elle va analyser l'image et elle va identifier, OK, il y a une baleine à cet endroit-là, donc on va la suivre. Donc le but, en fait, c'est une challenge, c'est d'essayer de leur, grâce à ce talent de scientiste, c'est de les aider à automatiser le processus pour qu'ils puissent identifier plus rapidement les baleines qui sont en danger, pour pouvoir, par exemple, les aider à sortir du filet de pêche dans les communautés. Alors, comment ça procède? En gros, il y a un dataset qui a été fourni par le New England Aquarium. Donc, il y a à peu près 11 000 images dans lesquelles il y a déjà, il y a plusieurs types de baleines, en fait, chacune a un ID. Donc, le but, en fait, donc ces images que vous avez, il y a un test set, un training set, qui est en ligne. Nous, ce qu'on propose, avec l'outil MATLAB, nous on propose d'utiliser MATLAB et vous pouvez le télécharger gratuitement pendant 1 an pour le challenge. Vous pouvez également utiliser l'outil que vous voulez. Les starter codes qu'on a fournis utilisent une approche du Visual Bag of Words. En gros, on a une image, on fait une extraction de paramètres automatique par l'approche Bag of Words. Et après, les submissions sont évaluées sur le critère du multiclass logarithmic loss. Et voilà, donc les prix, donc premier prix c'est $5 000, deuxième 3 000 $. Ça a commencé depuis le 27 août, la deadline est le 7 janvier. Donc voilà, donc, si vous êtes intéressé, donc vous avez ça, c'est le site pour lequel vous allez vous demander de télécharger l'outil avec toutes les librairies qui vont avec, image processing, machine learning, neural networks. Et donc ça c'est le site de Kaggle. Et donc voilà, si vous voulez, voilà, donc il y a déjà 66 équipes, 288 entries. Voilà, donc si vous faites comme Eric Cartman, join the fight. Ça sert une cause écologique, c'est un challenge. Ça fera éventuellement l'objet du prochain Kaggle Meetup, dans lequel on pourra brainstormer sur comment tacler le problème. Au côté Matworks, on aura un forum pour vous aider, pour suivre. Donc, vous pouvez étudier ce que vous voulez, vous pouvez faire du deep neural networks aussi. Il y a pas de. Voilà, l'idée, c'est vraiment de faire une approche outside the box. C'est un peu le but de Kaggle pour pouvoir aider cette cause.
Il y a des data scientists chez Matworks qui
Alors nous, on n'a pas le droit de participer, bien entendu, mais nous, en fait, ce qu'on fait, c'est qu'on va aider les gens. Voilà, c'est ça. Nous, d'un côté, enfin, moi, sur le j'ai un collègue aux États-Unis, et moi, sur le côté, on va dire Europe, où on va animer le forum sur lequel les gens vont poser des questions, soumettre des codes. Voilà.
Une question pour Amine? Ou alors vous lui parlez directement? Merci Amine. Le prochain Meetup des diplômes, c'est le 30. Le 30, c'est où? Ce sera annoncé plus tard. Ce sera annoncé plus tard.
Dans la rue.
Le prochain Meetup, c'est dans à peu près un mois, c'est toujours le deuxième mercredi du mois, on essaye de le faire. Je pense que ça va bien avec les vacances scolaires en ce moment. Donc on a toutes les dates pour toute l'année. Merci encore d'être venus. Merci à Rand et à Snip de nous sponsoriser pour ce buffet qui vient maintenant. Et puis, il faut parler.
Grab a drink. The drink. So run it now. Go upstairs.
Alors, ouais, parce que là j'ai